Hello there, Mr. Burrell here. We're in the middle of our factoring quadratics unit. We've talked about taking out a greatest common factor. We've prepared ourselves kind of mentally and physically to factor quadratics. And in the last lesson, we had a major crash course, covered a lot of different things about how to factor quadratic expressions. So today, really we're not doing anything different. We're just going to factor some more quadratics. I'm going to give you a couple other examples, and then on top of that, I'll give you some examples of special cases you might see and how to take care of those special cases as far as factoring quadratics. So by the end of this lesson, by the end of this video, I hope that you're able to factor a variety of quadratic expressions. For example, some of the ones I'll point out to you today is one of the B or C terms is missing. So if I have something like this, what do I do when either this term or this term is gone? Talk about how to do that. And also, I just hope by the end of this whole unit that you can recognize and make use of the structure of a quadratic expression and utilize that structure to help you to factor it. I think the structure and the pattern associated with quadratic expressions is really, really cool. Really, really, dare I say, beautiful. So I hope that you're able to appreciate and recognize that at the end of this lesson. So first of all, let's review. Let's go through each of the steps to factor this quadratic. So this isn't anything new. I'm just going to go through the steps. Notice I don't have the steps listed over here because hopefully I hope that in time you're able to factor these without those steps written out to you. So first, in this quadratic expression, I need to write it in standard form, which it is. Next, I need to factor out a greatest common factor. If we do this, you'll notice that there isn't one. There's nothing in common between all three of these terms, so I don't need to take out a greatest common factor. Next, I need to multiply A and C together and then find factors of that number that add to make B, or negative 5. So 6 times negative 4 is negative 24. B is negative 5. I need to find factors of negative 24 that add up to negative 5. So let's write out my factors. I have 24 times negative 1. I have 12 times negative 2. I have 8 times negative 3. I have 6 times negative 4. And I think that's it. And then on the flip side, I have negative 24 and positive 1, negative 12 and positive 2, negative 8 and positive 3, negative 6 and positive 4. So which of those factors, when I add them together, give me negative 5? This one right here, a negative 8 plus 3 is negative 5. So those are my two factors, negative 8 and positive 3. So I'm going to write those factors in these parentheses, x minus 8 over 6, because remember I write it over a. And then x plus 3, so I have negative 8 here, positive 3 here. Both of those factors are divided by 6, this a term right here. Okay. Sorry. Next step, I need to reduce each of these fractions if I can. So 8 divided by 6, I can reduce that to 4/3, because 2 goes into both of those, and I can reduce that to 4/3. Next, I need to see if I can reduce 3/6. Well, 3/6 reduces to 1/2. X minus 4/3, x plus 1/2. So now that those fractions are reduced, my next step is, bottoms up, I need to put these numbers here in front of x. So I'm left with 3x minus 4 and 2x plus 1. Then my last step would be, if I took out a greatest common factor at the beginning, I'd put that back here in front. I didn't have a greatest common factor, so that right there, that's my final answer. That is the factored version of that quadratic. Let's multiply these together, make sure that I did it right. So 3x times 2x, 3x times 1, negative 4 times 2x, negative 4 times 1. That's, I'm going to write this up here, 6x squared, and then I have 3x, and then negative 4 times 2x is negative 8x. Notice there's my 3, and there's my negative 8, and then negative 4 times 1 is negative 4. If I combine my like terms, I get 6x squared minus 5x minus 4, which indeed is what I started with. So good. Good. We've had a little bit of review. Let's move on. So I'm just going to do a handful of some special cases that you might see when factoring quadratics. Notice, the process does not change. We still factor them the same way. So the steps that we've discussed, those haven't changed. We just make some minor modifications. For each of these quadratics, start by labeling A, B, and C, and then doing like we usually do, following the steps, putting it in standard form, factoring out a greatest common factor, etc., etc. So first, I have 25n squared minus 4, and I've left this blank here for a reason. So this is A. Do I have a B term? No, so we might just write this as plus 0n. That would be my B term, because there's nothing there. There's 0 n's there. And then this would be my C term. So it's already in standard form. Next step in my step of factoring quadratics is I would find the greatest common factor. Is there anything in common between 25n squared and 4? No. So I can't take out a greatest common factor. Let's label my A, B, and C here. A is, 25. B is 0. C is negative 4. And A times C is negative 100. Okay. Well, my next step would say multiply A and C together, give me negative 100, and find factors of that number, or two numbers that multiply to make negative 100, that add up to B, or add up to 0. Okay, well, again, the process hasn't changed. Let's find factors of negative 100 that add up to 0. So I have, let's see, 100 and negative 1. I have 50 and negative 2. I have 25 and negative 4. I have 20 and negative 5. 6, 7, 8. And I think the last one is 10 and negative 10. And then I'd have negative 100 and positive 1, negative 50 and positive 2, negative 25 and positive 4, negative 20 and positive 5, and then negative 10 and positive 10 again. And if you struggle with finding these multiples, finding the numbers that multiply to make a negative 100, go back and watch my preparing to factor video. Okay, well, I need to find factors here that add up to 0. Well, 10 minus 10 is equal to 0. Negative 10 plus 10 is equal to 0. Negative 10, positive 10. So my factors are negative 10 and positive 10. Okay, let's move on. So I'm going to write these factors as n plus 10 and n minus 10. And then each of these are divided by a, or 25. So I wrote out my factors. Now I need to simplify each of those fractions if I can. So I have n plus, let's see, 5 goes into both of these terms, so I could reduce that to 2 over 5. N minus 10 over 5, that'd be n minus 2 over 5. I've reduced those fractions. Now, bottoms up. I'm going to write that as 5n plus 2 and 5n minus 2. I didn't have a greatest common factor, so that right there is my final answer. 5n plus 2 times 5n minus 2. Notice how these are related. Do you notice anything? It's not critical that you notice anything, but again, I want you to be able to notice the structure of these expressions and see how it helps you to solve these. Notice that I have these 5s here, and I have 25 here. Well, the square root of 25 is 5. Notice I have a 4 here, and I have these 2's here. Well, 2 is the square root of 4. I'm not going to press that any further. Take that as you will. But again, it's kind of cool to notice the structure of these expressions, see how they're expressed in the factored version of those quadratics. But again, notice how I didn't change my steps. I didn't change the way that I solved this problem. I just kind of had this special case where I had b being 0, and I was finding factors that added up to 0. Same process. Okay, here's another case. I have a quadratic expression. Let's list my a, b, and c values. A is 7, b is negative 9, and notice how there's no number over here by itself, so c is just 0. So again, we're going to go about this the exact same way. First, is this quadratic in standard form? Yes. My r squared, oh, this is supposed to be an r, I apologize. My r squared is at the beginning, then an r, and then my number at the very end. So it's already in standard form. Let's see next, can I take out a greatest common factor? Well, there's not a term here. So I just have these two terms. Let's see if there's anything in common between those terms. Well, there is. There's an r in common between both of those terms. So I can take out an r, and I'm left with 7r minus 9. Okay. Well, notice here, I no longer have a quadratic expression in here. There's no r squared, so I don't need to factor anything. I'm done. We're going all the way back to the first concept in this unit where I took out a greatest common factor, and in this case, that's as far as I need to go in factoring this quadratic expression. I can skip all the rest of my steps now that I've taken out a greatest common factor and there's not a quadratic left in here. I'm done. So that's my final answer. We like problems like that, don't we? So when I have two terms like this and I can take out a greatest common factor and be left with something that's not quadratic, I'm finished. All done. See, notice how the process didn't change. I just cut my process short. Okay, let's do one more of these types of examples. So again, notice that this is 2x squared plus 0x minus 98. Whoops, 98. So, first step, is that in standard form? Yes, it is. Second step, can I take out a greatest common factor? Well, I could take 2 out of both of these terms. Again, I'm going to ignore this for a minute. I'm going to take 2 out of both of these terms. 2, and I'm left with x squared minus 49. X squared minus 49. Okay, so let's find my a, b, c values. Again, I'm looking at this chunk right here. A is 1, B is 0, C is negative 49, because I have x squared plus 0x minus 49. Here's A, B, and C. So A times C, negative 49 times 1 is just negative 49. I need to find factors of negative 49 that add up to 0. Well, I have 49 and negative 1. 49 times negative 1 is negative 49. I have 7 and negative 7. What do you know? 7 minus 7 is 0. Notice again how 49 is a perfect square. Okay, I'm going to write my factors as x plus 7 and x minus 7, putting a in the bottom of each of these. Well, 7 divided by 1 and negative 7 divided by 1, that's redundant, so I just have x plus 7 and x minus 7. And then I'm going to put this greatest common factor back out in front. So my final answer is 2 times x plus 7 times x minus 7. Notice again how the square root of 49 is equal to 7. Take that as you will. So those are some of the special cases that I wanted to address when it comes to factoring. I hope you noticed and are understanding and appreciating how each of these quadratic expressions are set up, their structure, the patterns you're starting to see. So I think that's one of the funnest part of these units, seeing these patterns, kind of working out these puzzles. Okay, I'm going to work out one other example with you, and then we'll call it good. I'm going to go ahead and do this one. You can do this one later if you so desire. We're going to do this one. So first step, I'm going to factor this quadratic. First step, is it in standard form? Yes, it is. Second step, is there a greatest common factor? Well, let's see. And I'm whizzing through this. If you need to find the factors of these, you can using our factor trees. There's nothing in common in all three of these terms. So I'm going to move right on to the next step. Here's A, B, and C. Need to multiply A and C together, so 54. Find factors of that, or numbers that multiply to make 54 that add up to 15. Well, I have 54 and 1, 27 and 2. What's 54 divided by 3? Anybody know? See, and the math teacher needs to pull out his calculator every now and again. That's 18 and 3. Let's see, 54 divided by 6, 9 and 6. I don't think there's anything in between there. I think that's it. I think those are all the factors. And then all the negative versions of those. Negative 54 times negative 1 is positive 54. Negative 27, negative 2. Negative 18, negative 3. Negative 9, and negative 6. Which of those, when I add them together, will give me 15? Well, that one. Right there. 9 plus 6 is equal to 15. So let's do this. X plus 9, x plus 6. Divide by a, or 2, in each of those cases. Next, I need to see if I can reduce either of those fractions. I can't reduce 9 over 2, but I can reduce 6 over 2. 6 divided by 2 is 3. Now that I've reduced the fractions, bottoms up, I have 2x plus 9 times x plus 3. Last step, did I take out a greatest common factor at the very beginning? No, I did not, so I don't need to put anything out in front. That right there is my final answer. 2x plus 9 times x plus 3. You can go ahead and multiply those back together by yourself if you want to confirm that we've done this correctly. But that's it. So, that's the entire unit of factoring quadratics. Notice how they kind of built upon each other. So all the tools that we learned at the beginning of this unit were to help us to factor quadratic expressions. So I hope that you're now able to factor a variety of quadratic expressions, a bunch of different types. Specifically, we talked about when the B or C terms were missing, how we take care of that. And I hope you now recognize and appreciate a little bit more the structure of these quadratic expressions, and hopefully you're able to notice the structure, look at a problem, and utilize how that problem is set up in order to help you to factor it. And again, this unit is preparing us, basically this whole unit is preparing us for the next unit when we're talking about solving quadratic equations. So something to look forward to, something to anticipate. I hope that video was helpful. Please don't hesitate to let me know if you have any questions whatsoever, and I hope that you enjoyed that as much as I did.